Here in this video, we're going to look at the polynomial division and the remainder theorem kind of at the same time. And so what the remainder theorem tells us is basically if we were to plug in a number for x into some polynomial and we would get 0, that means that number for x is an x-intercept. In terms of division, if I divide a polynomial by some factor, let's say like divided by x minus 1, then what that means is that if I divided it and I had no remainder, this number is an actual 0. Now, we use division to help us factor problems or to write very high degree polynomials into factored form. Two methods of division: synthetic division, long division. Synthetic division, you do if you're dividing by a linear factor, and it's easiest when this coefficient is 1. You can do synthetic division when this coefficient is not 1. You just got to be very careful. However, we're just going to do coefficients of 1 here in this video, and then when it's not 1, or if it's a different degree, we're going to do long division. So the way synthetic division works, you take the 0 of this factor. So the 0 of this factor is x is equal to 1. And I'm going to put 1 in the box. And then what you do is you start and you write the coefficients of the polynomial you're dividing to when it's written in standard form. So every coefficient. Now I got to make sure all degrees are accounted for. So if I was missing a degree, let's say I was missing degree 1, I'd have to put a 0 there, but I'm not missing degree 1. All right, so all of those coefficients are right here in my top row. 3, 7, negative 17, 5, 5, and negative 1. The way synthetic division works, you drop the first number down, and then you take that number and you multiply it to what's in the box. So 3 times 1 gives me 3, and then we add. 7 plus 3 gives me 10, and then I repeat. I take that number, I multiply it by what's in the box, that gives me 10, and then I add, and I get negative 7. And I continue. Negative 7 times the number in the box is still negative 7. I add, that gives me negative 2. Negative 2 times the number in the box gives me negative 2. I add, that gives me 3. 3 times the number in the box gives me 3. And I add, that gives me 2. So 2 is my remainder. So what that tells me is x minus 1 was not a factor. So it's not a factor. Now we can take this division and we can rewrite this polynomial in like a fraction form. And so through the process of division, what happens is this 3 is the coefficient of the first term, or the degree of the first term, since I divided once, is going to be 1 less than the degree that we started with. So I started with degree 5, that means this is degree 4. So I'd have 3x to the 4th, and then I work my way to the right, decreasing my degrees, plus 10x to the 3rd, minus 7x squared, minus 2x, plus 3. Now when you get to the remainder, it's going to be plus the remainder over what you're dividing by. All right, we'll do it again here. So now I'm dividing that polynomial by x plus 2. The 0 of that polynomial is negative 2 that we're looking at. So I put negative 2 in my box. I start writing all of my coefficients. So I got 9, 16, negative 3, negative 27, and 10. So I have 9x to the 5th, 16x to the 4th. I don't have any x to the 3rd, so I'd have to put 0 to account for the 0x to the 3rds. Minus 3, minus 27, minus 10. Now we start our process of synthetic division. Drop the first number down. Multiply by the number that's in the box. 9 times negative 2 is negative 18. Then we add. That gives us negative 2. Multiply by the number in the box. 4. Add. Positive 4. Multiply by the number in the box. Negative 8. Add. Negative 11. Multiply by the number in the box. 22. Add. Negative 5. Multiply by the number in the box. 10. Add. Makes 0. So we have no remainder. What that means is x plus 2 is a factor, which also means that x is equal to negative 2 is a 0 of the function. So that is a factor, and that is a 0 if we were trying to write this thing in factored form. So what this division has yielded, remember when we degree, it decreases the degree of the polynomial by 1 of what you started with. So I end up with 9x to the 4th minus 2x to the 3rd plus 4x squared minus 11x minus 5. Now let's do some division when we're not dividing by a linear factor. We're dividing by something much larger. And so I'm looking at this degree 5 polynomial and I'm dividing by a degree 3 polynomial. So you cannot use synthetic division for this. We have to do long division. And like the name, this is often very long in process. So I'm going to write what I'm dividing by. Now the process of doing this is very similar to how you would divide two numbers into one another by hand. And I call it the old school division sign. So I'd have inside of what I'm dividing would be x to the 5th plus 11x to the 4th plus 29x to the 3rd minus 6x squared. You have to make sure you account for all terms, even if they're not there. So if I was missing a term, I'd have to put a 0 in its place. All right, so here's my division problem. The way this works is you always want to take the front number here. So in this case, the x to the 3rd, and make it be the front number of the line that you're working on. So like I'm starting with the x to the 5th. So I want to know, what do I do to x to the 3rd to make it become x to the 5th? Well, I would multiply it by x squared. And so I figure out the multiply x to the 3rd by x squared to make the x to the 5th. You then take the x squared and you're going to times it to all the terms of what you're dividing by. So I'd make x to the 5th plus 6x to the 4th minus 4x to the 3rd minus 3x squared. Long division, we're going to subtract. And then we're going to write down what we're left with. So after I subtract, the x to the 5ths cancel. 11 minus 6 is 5, so I got 5x to the 4th. 29 minus negative 4 is going to be positive 33x to the 3rd. Negative 6 minus negative 3, negative 3x squared. And if you want, you can go ahead and drop the next number down. Now we turn around and we repeat our steps. So I want to make that x to the 3rd become 5x to the 4th via multiplication. Let me change colors, go purple. To make x to the 3rd become 5x to the 4th, you'd have to multiply by a positive 5x. And so I would then take that 5x and multiply it to all of the terms into that equation again. And so it'd make 5x to the 4th plus 30x squared minus 20x plus 15x. And remember, we're subtracting. And I start subtracting. I'm going to have, this was supposed to, I forgot my exponents are wrong. So let me erase this one. That should be 30x cubed and 20x squared there. And I'm supposed to be the guy making the video, and I make an algebra mistake. All right, so got that fixed. I subtract. We'd have 3x to the 3rd. Negative 3 minus negative 20 makes positive 17x to the 2nd power. And then 15x minus 15x makes 0. And we're going to drop the last number down, so we'd have plus 15. All right, now we do the process another time. You keep going until the exponent of what you're left with is smaller than what you're dividing by. So I got to do this one more time. Pick another color here. Let's go with blue. And so I want to make the x to the 3rd become 3x to the 3rd. So I'm going to multiply by positive 3. And then we're going to multiply everything by 3. So it gives us 3x to the third plus 18x squared minus 12x plus 9. And now we subtract. And we have the x to the thirds cancel. We have negative x squared plus 12x plus 6. All of that is my remainder. So the way we would write our answer is we're going to write what we have on the top. So we'd have x squared plus 5x plus 3 plus our remainder. Our remainder is negative x squared plus 12x plus 6 divided by what we were dividing by originally, divided by x to the third plus 6x squared minus 4x plus 3. Okay, one more long division problem here. Make sure we get the hang of it. All right, so I want to divide those two polynomials. Make sure when I'm doing this process, I'm accounting for all the terms. So I got x to the third minus x squared minus x plus 2. All the degrees accounted for, dividing into 10x to the fourth minus 20x squared. Well, I need to have x to the thirds accounted for, so 0x to the third minus 20x squared plus 10x plus 20. All right, so the process long division, I want to make the front numbers the same, front terms the same. So I want to make x to the third become 10x to the fourth. I would do that by multiplying by 10x. Multiply that 10x to all of the terms over here on the left-hand side and write down what we get. We'd have 10x to the fourth minus 10x to the third minus 10x squared plus 20x. Long division, subtract. Top minus the bottom. X to the fourths cancel. We'd have 10x to the third minus 10x squared minus 10x. Drop the 20 down. Plus 20. And then we're going to repeat the process. I want to make x to the third become 10x to the third by multiplying. So to do that, we would multiply by positive 10. So I'm going to multiply all the terms on the left by positive 10. 10x to the third minus 10x squared minus 10x plus 20. And now we subtract, and everything will cancel, and we have 0 for a remainder. So this polynomial here, this degree 3 polynomial, is a factor because the remainder is 0. So our answer here through the division of those two polynomials is just 10x plus 10 because there is no remainder.